All right. Leod Alliance says GER or oil rig. You can use either one of those to help us for today. So let's go ahead and talk about what we're going to do today. Today what we're going to do is talk about redox reactions. And really, a redox reaction is any reaction in which electrons are transferred between atoms or ions. And so if an electron is transferred from one atom to another, it is going to be considered a redox reaction. And what redox means, it means reduction oxidation. And so that means there's something being reduced and something being oxidized. And we're going to talk about what those are in a moment here. So reactions where electrons are transferred from one atom to another are called oxidation-reduction reactions. And they're also known as redox reactions for short. Something to keep in mind is that if an atom loses an electron, atoms that lose electrons are being oxidized. Notice that it says Leo. Atoms that gain electrons are being reduced. And so Leo says GER helps us remember what is being oxidized and what is being reduced. And so if something loses electrons, it's oxidized. If something gains electrons, it's reduced. And that's how we can determine if something is oxidized or reduced. Now, oxidation numbers, so we're going to talk about oxidation numbers, tell you the oxidation states, and they are the charge that an atom actually has within an ionic compound, but when in a molecular compound, they represent the charge that the atom would have in the compound. And so essentially, oxidation numbers tell you how many electrons are being pulled away from an atom, or how many electrons are being pulled towards the atom. And so let's go ahead and take a look at this example here. Now I want you to think about what is being oxidized and what is being reduced. So notice how the iron was losing electrons. So notice how the iron, you can see the electrons coming out. So the iron's lost electrons. Now the oxygens are gaining electrons. So I want you to think about using Leo Alliance says GER. What is being oxidized, what is being reduced? So think about that. So if something loses electrons, it's being oxidized. If something gains electrons, it's being reduced. So what's being oxidized, what's being reduced? In this situation, the iron is being oxidized. The iron is losing electrons. The oxygen is gaining electrons, so it's being reduced. And there it is. Now, the previous thing, so this is an ionic compound. Ionic compounds are the transfer of electrons, but what about covalent compounds? Covalent compounds, there's not a transfer of electrons, but sometimes there's an uneven sharing of electrons. Sometimes one atom is pulling the electrons closer to itself. And so even though there's not a full transfer of electrons in this situation, notice how there is a pull of electrons to the fluorine. And so because of that, the hydrogen actually, we say it has an oxidation number of 1+, and the fluorine has an oxidation number of 1-. And I'm gonna talk about how you can determine that. So I haven't talked about that yet. But the point here is there's not a transfer, they're not a full 1 positive, full 1 negative, but there is a sort of gravitation of the electrons towards the fluorine. All right, so these numbers are used to determine what is reduced and what is oxidized. So when we're talking about oxidation numbers, and we're talking about how to assign oxidation numbers, we can use these to help determine what is reduced and oxidized within a chemical reaction. And they are often written above or below each element in a chemical reaction to keep track of what is losing or gaining electrons. And so when assigning oxidation numbers, you want to use the following rules in order of priority. So you want to start with rule 1 and go all the way down. And so what I'm going to say is I'm going to go through the rules, but it's really going to come together when we go through the practice problems. It's the practice problems that really bring it together. So free elements have an oxidation state of 0. So for example, we had Cl2 or just iron or S8. If there's no charge associated with them, we say that they have an oxidation state of 0. Now, a monatomic ion will have an oxidation number or oxidation state that is equal to their charge. All right, so it's equal to their charge. So notice how sodium has a 1 positive charge. Notice how chloride has a 1 negative charge. And so those are equal. So within an ionic compound, whatever the charge of the ion is the oxidation number. Now, group 1A metals will have oxidation states of 1 plus in all of their compounds. Group 2A have an oxidation state of 2 plus in all their compounds. In their compounds, non-metals have oxidation states according to the table that's in your notes there. Non-metals higher on the table take priority when assigning oxidation states. And so when we go through examples, it's going to make more sense. But you want to assign the oxidation numbers in order of that table. Now this is really important. The sum of the oxidation numbers in a neutral substance is equal to 0. And so let's say we have water, for example, H2O. That's a neutral substance. Whatever the oxidation number of hydrogen is and the oxidation of oxygen is, if you add those together, it has to equal 0. Now keep in mind there's 2 hydrogens, so whatever the oxidation number of each hydrogen is, added together, plus the oxidation number of the oxygen added to that must add up to 0. And again, we'll go over an example of this in a moment. Now, for polyatomic ions, the sum of the oxidation state must add up to the charge of the ion. So here's an example here where we have NO3. We're going to learn that oxygen is a 2 negative. So we're going to assign oxygen a 2 negative. And we know that there's 3 oxygens. We know that the nitrate is a 1 negative, and so the nitrogen must be a 5 positive to add up to that 1 negative. And so I know that this isn't going to make sense necessarily. It will make sense when we do the guided practice problem. That's when it's going to make sense. So just sort of grasp what you can for now. All right, so let's talk about redox reactions themselves. So we just talked about assigning oxidation numbers. Let's talk about redox reaction. This is where we're going to use Leo the line says GR. So in order to identify a redox reaction, you have to write the oxidation numbers for the elements for each element within the entire chemical reaction, all right? And you have to do it on the reactant side and the product side. Now, a substance that has the element that has been oxidized will have an oxidation number that becomes more positive. Okay, so when we go through an example, we'll talk about this. So the reason why that is because a substance that is being oxidized is losing electrons, and if it's losing electrons, it's becoming more positive. A substance that is being reduced is gaining electrons, so the oxidation numbers become more negative. And so here's an example here. So notice aluminum. Aluminum is alone by itself. It has a charge of 0, so its oxidation number is 0. And then copper is starting off with a 2 positive charge, and so its oxidation number is 2 positive. Now notice when they become products though, notice how the aluminum becomes a 3 positive and the copper becomes 0. So the aluminum went from 0 to 3 positive. And so how does it go from 0 to 3 positive? How does it have to lose electrons or gain electrons to become more positive? Well, again, electrons are negative, so it's got to be losing those electrons to become more positive. So if it's losing the negative electrons, it's becoming more positive, and if it loses electrons, it's oxidized. Leo. Now, copper is a 2 positive, and it becomes 0. So how does it go from positive to neutral? Well, the way that works is it must be gaining electrons, and if it gains electrons, it's being reduced. So that's the GR. So Leo line says GR. So often you'll be asked to identify the electrons to more clearly illustrate the process of oxidation reduction. And electrons will be written in the half reactions using the symbol E with a negative sign there. So that's how we'll represent electrons within the half reactions themselves. Oxidation and reduction must happen at the same time, and that makes total sense because what is oxidation? Oxidation is the losing of electrons. Well, if something is losing electrons, that means something else must be gaining electrons, and so you cannot have oxidation without reduction. So they both have to occur at the same time. So if you're doing something and you see that there's something being oxidized, but something is not being reduced, that means you're doing something wrong. And that's it. So I know there's a lot going on there. So we went over what a redox reaction is. A redox reaction is a reaction where there's a transfer of electrons. Then we talked about oxidation numbers and assigning oxidation numbers to elements. And there's the rules, and we'll go over examples of that in a moment. What I want to really highlight, though, is while in many situations an oxidation number is the charge of an atom, oxidation numbers are not the charge of the atom, because you can have compounds where the atoms don't have charges, but they still have an oxidation number. So it's not the same as the charge, although atoms that have a charge, it is the oxidation number. So oxidation numbers are slightly different when considering that. Then we talked about oxidation and reduction reactions and identifying something that has gained or lost electrons within the reaction. So you can have reactions that occur where they're not redox reactions. So I know there's a lot to process there, but we're going to break that down in the guided practice problems, and maybe just review your notes one time or two times after the guided practice, because I think that's where it'll come together, is watching the guided practice and then just reviewing your notes real quick and reading through them. All right? Come with questions. Have a great day.